Okay, we're coming along. The board's all drilled out for the moment, and we've got them numbered. We remember to put numbers on them. This is board 1 on paddle 1, and that's going to line up to our witness marks on the heatsink 1 and 2. I know it's hard to see, but it's easier to see when you're up close. And this looks kind of silly. This is the collector paddle for the power. And it'll be handling hopefully no more than 25 amps. And the emitter paddle, hopefully that'll handle the current. I'm not sure. It's a little bit more than a half an inch wide, so it should handle it. But I think what we're going to do is we're going to fold and solder a strap to it so that it can handle more current. Now we're not quite finished drilling, because if you know anything about TOW 3 packages, the screw is going to go through here and it's going to contact this plane, but it's also going to contact this plane, shorting out the collector to the emitter. Well, we ordered some washers for a number 6 screw that are plastic nylon shoulder washers, and they'll probably require us to drill this out a little bit. So when we get them, we'll figure out exactly how much we have to oversize that hole, and that will prevent any arc event or any issue with the collector making a short circuit to the emitter side of the circuit. These holes are a little goofy, or I should say the pads are a little goofy. They're all asymmetrical, of course, because they're hand drawn. I use a paint pen. I don't have time for using a really nice board program at the moment, and I've always been hesitant to use board programs because the print sometimes comes out strange and it may not fit, it may not scale properly. But really the reason why I didn't use photolithography on this was because the board is so custom that to do photo, I'd have to really prime the board, and I would have to put the photosensitive chemical film on the board myself, and I'm not good at that kind of thing. That requires good painting technique, and that's pretty hard. I've tried to do it in the past, and it just doesn't come out right. Alternatively, you could buy a pre-sensitized board, do the photo first, and then do all the machining as a secondary process. And that's really what you should do, is do all the layout and the lithography first, so that you've got all your datums all lined up, and follow the process the right way. But I'm doing it backwards. I'm doing all the machining first, because the machining gives me the datums I need in order to do all the layout work. And this is basic. It's really basic stuff, so it's okay. I can do it backwards. Plus, this is a one-off, so this is really a prototype. Anyway, it looks kind of strange. We're going to be soldering SMD resistors in here. So we have a 330 ohm feedback resistor that goes from the base to the emitter, and then we're going to have a 1 ohm resistor from the base control line to the base, just to prevent pushing a lot of excess current into the base. So it's to help prevent damage to the transistor. And then what we're going to do is we're going to loop the power resistors, because each emitter needs a power resistor of a 0.1 ohm, 3 watt, and that's going to solder, and then it's going to loop, and then it's going to loop, and it's going to solder to these paddles here. So each one of these is going to be carrying 3 amps max. So that'll handle 20 amps right there, no problem. Just that small size. And then each one of these holes is going to receive a pin socket. So we're not soldering to the transistor, we're soldering to a socket cup receptacle, and each one of those is capable of 8 amps. So this is going to be well overbuilt, and it should handle the current fairly easily. We have 2 tie points on the collector, and we have 2 tie points on the emitter, and what those are going to do is they're going to facilitate a copper strap that's going to go from the collector from board 1 to the collector of board 2, and we may double them up. So we'll fabricate a copper strap, and we'll punch out the holes for the screws, and then we'll put a tube of heat shrink over it, so it makes it a big old fat wire. And I think that will be good for the strap connection, and that way the current goes this way and it goes this way into the second board, which is right here. So I'm hoping there won't be too much loss in that connection to this board. So I'm hoping it's not like 25 amps and 20 amps. That would put a stress on the transistors, even though they can handle it. I'd prefer that not happen. We'd have to do a basic back of the envelope calculation, figuring that copper strap is maybe 75 milliohms, and see what the voltage drop across that is. So that would take math, and I don't really care about doing that. You should do it, but yeah, I'm not going to bother with that until the thing doesn't work, which I'm not sure. It may not work, but we're learning and we're goofing around and making things, and it should work. I think it'll work. So those are our layout. Came out really nice. Nothing's going to short, which is amazing. And we got to put the connections in. And once that's all built up, we should have a pass transistor capable of handling 50 amps continuous current, 100% duty, with plenty of headroom